Hey, Jody here. Thanks for watching another video from weldingtipsandtricks.com. Let's do it.
In this video, you will see some arc shots of the previous stick welding video with 3/16 diameter 7018 so we can compare puddles, a 7024 electrode multipass fillet weld along with plenty of arc shots, problems we encountered using the 7024 rod, cut and etch test for penetration, and then also a quick refresher on some of the more common stick electrodes for steel. Let's take a really quick look now at the previous stick welding video I did where I was using 3/16 diameter 7018s at 230 amps. The 7018 puddle is much more easy to distinguish between molten metal and molten flux than with a 7024. That is one big difference. That, along with the fact that a 7024 is not rated for all positions. So even though they say it's for flat and horizontal, when you start getting into more horizontal rather than flat, you can get some issues. And we're going to see some of that today. That big rod on the top, even though the one under it is the same diameter, 3/16, it's much bigger due to all the extra iron powder in the flux. So previously we used 230 amps for the 7018. For the 7024, because of all that extra flux, extra iron powder, 260 amps is what we're going with here. 7024s are known as a drag rod, also kind of referred to as jet rod. That's a trade name of Lincoln's 7024. But they are used for large single pass welds primarily. And when they say flat and horizontal, like this is actually considered horizontal. It's a 2F fillet weld, but it's almost the same as running a bead on flat metal. Technically it's not flat, but it's like flat. But when I get on up the second and third passes, it'll be more like horizontal. And we'll see what happens there. Now you can see all that swirling mess in that slag. You don't have to deal with that with 7018. It's a different rod with different characteristics. And so all that extra iron powder along with other additions makes that puddle and flux cool off a lot slower so it doesn't stick and cool quickly enough to weld vertical uphill or things like that. But it does lay down a nice smooth bead because it does cool nice and slowly, and that bead's almost 3/4 of an inch wide. Here's a side-by-side comparison. The top one's a 7024 with all that swirling stuff going on. The bottom one's easy to define. I definitely prefer the 7018 for a lot of reasons. The 7024 is not low hydrogen, so you can't use it where low hydrogen rods are specified. It's just got its place in large single pass fillet welds, and you can deposit a lot of metal really quickly. If you're outdoors and you still need that production on a single pass weld, it does have its use there. On the second pass of this 3-pass multi-pass fillet weld, it also did a pretty good job. I've got that crowned up bead on the bottom kind of supporting the molten slag there, and so it did a pretty good job. I'm just trying to drag it along with a nice tight arc, almost letting the metal support part of the weight of that rod, and I'm just not doing anything a whole lot different than I was with the 7018 in the previous video. We'll chip this off now, and it also looks pretty good, pretty smooth ripples, but I did notice a little bit of a ridge in the center of the bead that I didn't notice on the previous bead. So it's already starting to have an effect. Gravity's already starting to have a little bit of an effect here. And here comes some problems on this third bead. I'm trying to angle it more straight in there, but right about here that it just drips. And there's going to be more problems than that. Not only does the slag drip sometimes, but sometimes it creates this really strange ridge. It looks as if there were two beads there where there was only one run, and I didn't notice this really going on as the puddle was solidifying, but it looks like there were actually two separate beads run there, especially right here. And there weren't two, there was just one big bead, so I tilted it up like this to be more like a flat position, a 1F position, and then ran into another little issue. This puddle is so hot that while I'm watching just the immediate area around that electrode, it's hanging back there so far and just chewing away the corner. So when you're welding near an edge, that's a really hot puddle, and it can chew off the edge and leave it really choppy with some undercut there. With the slow cooling and the big hot puddle, it'll make a smooth bead, and you'll get peelers every now and then like this. I even got this one to peel, even though I have that choppy edge with the undercut. So the way I think to remedy that is just stay completely away from any edges, or completely consume the edge like I did here with a whole nother layer. That worked out pretty well. So I put it on the bandsaw, and you're going to cut it right down the middle here to do a cut and etch test and just see not only on the penetration of the previous video where I welded with the large diameter 7018s, but let's see what happened here with this layer of 7024s. I think I see a little tiny pore in there. We'll see. Etch should bring it out rather than disguise it, but we'll see what happens. We'll get a different angle on this thing now, and I guess it was a piece of grinding dust or something because it just wiped right off. So that's a lot of different passes, a lot of different layers. It did get adequate penetration. It didn't actually punch too deeply into that root with that large diameter 7018. Sometimes large diameter rods, you have trouble getting complete penetration into the very root of the joint just because of the diameter of the electrode, but this one did pretty good. All right, let's do a quick summary now of the most commonly used stick rods. These are clips from previous videos. So first up, the 6010, which is a fast freeze rod. It's DC only, but all position rod. Usually you use some type of whip and pause type motion here, and you get very distinct ripples because that puddle freezes so quickly with every motion of the rod. 6010 is used an awful lot for open butt root joints, and usually you're using somewhere between a 30 to a 37 or 40 degree angle on the bevel, and you just ram that rod in there and you're basically almost welding it from the back side. You keyhole it out, and basically there are a lot of techniques you can use. You can set it up where you can just drag it. You can do a little keyhole whip and pause. Lots of ways to skin the cat. 6011 is like a cousin of a 6010, but can be used on all polarities. And it's good for doing portable work. Like I've got this little inverter machine here that will not run a 6010, but it will run a 6011. And I did a little quick repair on a friend's garage door, and it was just a ticket, not worried about any wind. Ran it off a 115 drop cord and did a nice little job. Got his garage doors repaired. Very easy to weld downhill, horizontal, side to side, uphill, overhead. Doesn't matter. All positions. Also run really nice off an AC buzz box. So will a 6013. An awful lot of 6013s are used on AC buzz boxes. In fact, I did a video a while back. I compared DCEN to EP to AC. 3 different welds, cut and etched all of them. The puddle actually looked almost identical on all 3 welds. Very subtle differences, no matter if I was on DCEN, DCEP, or alternating current, just a little bit, maybe a little bit more spatter on alternating current. But cut and etch test and the visual all looked very similar. Not much difference at all. Big difference when you get out of position for the different polarities. 7014 welds a lot like a 6013, puts down a little bit more metal. I kind of like it a little bit more. But it is rather a lot like the 7024 in the appearance of the puddle. Like it's just kind of hard to distinguish puddle from slag. It's not a defined, crisp line like the 7018, but it does have its place. Not a low hydrogen rod, does not need to be kept in an oven. Rated for all positions, so a multi-pass weld like this, all beads run just about the same. I did a cut and etch test on this one too. As you can tell, I like to test things. And obviously a cut and etch test just tests one cross section, so you could have defects other places in the bead, but what it does is just gives you information. It just helps you develop a procedure, helps you get confidence in what you're doing. It's a really good training tool. It's especially helpful when you can do it immediately after welding, so you can correlate what went on with a puddle and the result here. You can see how much it actually penetrated versus what it looked like. 7018 electrodes are classified as low hydrogen electrodes. They are the backbone of the construction industry here in the USA anyway. And they're all position overhead welds like this are no problem. The best technique I have found is just pretty much weld with the same heat, just maybe a little bit less than I would flat. Hold a tight arc, don't get carried away with too much angle. Set the machine hot enough where when you hold a tight arc it won't stick, then hold a tight arc. That's the best advice for overhead welding I could give anybody. And a nice quick cut and etch test will eliminate any doubts on your settings or procedure. 7018s are sometimes required to be run using stringer beads, a limit on how wide you can go with the bead, but the weave passes are still used. It just depends on code requirements. This is a 332 7018 going uphill on a cover pass on a practice plate, preparing to weld on pipe. A lot of pipe welds are still done using the weave technique. If you need practice on stringer welds or stringer beads, just patting beads on a piece of plate is some of the best practice you can get. You'll get more arc time, more practice time, less prep time, and stacking beads like this is just some of the best practice there is. I'd like to remind you that the way I support these videos is with my online store at weldmonger.com. I would very much appreciate it if you would give it a visit. I'm off to shoot another video. We'll see you next time.